Which parallelogram has the same area? What is the area? All right, so remember, area is the total number of square units a figure encloses. So even though we don't have a base and a height, we can figure out how many square units the figure encloses. So if we were to sketch out the lines behind, it would look something like this. And then you can count the square units. So we have 1, 2, 3, 4, 5. 5 3 times, or we have 3 5 times. 5 groups of 3 or 3 groups of 5. So the area for this is 15 square units. I'm gonna put it up here. 15 square. I'm just gonna put unit squared. 15 square units. And remember, unit in math means 1. You could also use the formula. So since the shape is a rectangle, you use the formula area equals the base times the height. So we have 3 squares going across the base, and we have 5 squares going across the height. So three groups of 5 is going to give us the total 15. Area of the rectangle is 15 square units. All right, so now we have a parallelogram. Now remember, a parallelogram is just a shifted rectangle. So if I were to decompose this rectangle right here, at this right here, I'm cutting off 2, 1, 2, and a height of 1, 2, 3. So if I cut this part off right here, which in math terms, we call it decompose. If I decompose that there and then move it over to the other side, still 2 units here and 3 units high, 1, 2, 3, I will make a perfect rectangle. So my perfect rectangle will be here. So you have to remember, a parallelogram is just a shifted rectangle. So now my new rectangle looks something like this, or my new shape. Now notice that all I did was decompose it and moved it over to the other side. So since a parallelogram is just a shifted rectangle, it's going to use the same formula as a rectangle, which is area is equivalent to the base times the height, because a parallelogram takes up the same number of square units as a rectangle. So since I decomposed this is gone. I decomposed it and made it a rectangle. So now I'm going to get the base. So if I count the square units along the base, 1, 2, 3, 4, 5, I can substitute it into my formula. And my height, 1, 2, 3, from the bottom to the top. So I'm going to put 3 right there. And then the area is 15 square units again. All right, so now I have another shape, not sure if it's a square or a rectangle. So I'm going to just use area equals base times height. If it's a square, then I will use side length square, but since I don't know what the base and height is, once I count it, I'll know what shape it is, but I'm just going to go with base times height. So I'm going to get my base, 1, 2, 3, 4. I'm going to substitute it in. Definitely sure it's a rectangle. Then I'm going to get my height, 1, 2, 3, 4 square units high. And 4 times 4 is 16. Now, this is a square because all sides are equal. So you could have just we could use area equals side length square, and that side length is 4. 4 squared is 4 times 4, which is 16. But because I didn't know if all sides were equal, when I substituted in, I just used base times height. So this has an area of, this square has an area of 16 square units. Now I want to find the area of this parallelogram, which is number 4. I'm going to use my formula. Area of a parallelogram is equivalent to base times the height, because a parallelogram is basically just a shifted rectangle. Or if you decompose the parallelogram and compose that piece to the other side, it'll take up the same number of square units. So I'm going to get my base here, 1, 2, 3, 4, 5. And then I'm going to get my height, which goes from here all the way down here. So I'm going to count 1, 2, 3. Substitute that in, and that's going to give me 15 square units. So this one is also 15 square units, or units squared. So parallelograms 1, 2, and 4 have an area of 15 square units. So I'm going to write 1, 2, and 4. And that's my answer there. Let's go to the next question. All right, now this question here, you have to use ratio. You have to use equivalent ratios. You have to understand that concept, and you have to understand area. So it says, what is the ratio of the area of the trapezoid to the area of the combined area of the triangle, the combined area of the triangle? So we want to put the triangles together. Now, what you need to remember about ratio is order is important. Order is important. So they want the trapezoid. So I'm going to write that order down. Trapezoid, the area of the trapezoid to, or I'm gonna put a colon in the middle since they have a colon here, to, which is the same thing, to the area of the combined triangle. So put both triangles. All right, now this you could do this two different ways. You can find the area of the trapezoid, and then you can find the area of the triangles. If you know the formula for a trapezoid, remember when you make a trapezoid, you make a copy and rotate it and compose it. And since you only want half of the square units, you could use the formula area of a trapezoid is equivalent to half, because you only want half of it when you make the copy, just like a triangle. Triangle is half of a rectangle. Since a parallelogram, you make a parallelogram, you will use base times the height, but you will add the bottom base to the top base, which will be base 1 plus base 2, and then you will multiply times the height. Now this one gets tricky because the length from here to here is 12. The length from here to here is 12, and you have to know what the length from here to here is. So you actually will have to take the 12, take the whole 12, which is the length down here, take away the 3 from here, and then take away another 3 from here, and the rest is going to be the length from here to here, which in this case is 6. So 3 plus 6 plus 3 must add up to the whole 12 because a rectangle have two sets of parallel sides. So you will use 1/2 times the sum of 12 plus 6, or you could just add it, times the height, which is 6, and that'll give you the area of the trapezoid. Then you use your formula for triangles, 1/2 times the base times the height, substitute in 6 and 3, and do the same thing here. That's too much work. But if you want to do that method, you can. What I would do is find the area of the whole rectangle. So the whole rectangle is made up of both the triangles and the trapezoid. So I will find the area of the whole rectangle, which is, I will use the dimensions 12 by 6. I'm going to use my formula area equals base times height. If I find the area of the entire trapezoid and I take away, I can easily find the area of the triangles. Find the area of the whole trapezoid and take away, if I find the area of the whole rectangle and take away the triangles, both triangles, I will have the trapezoid. Because if I take away the two parts, the last part that's left is the trapezoid. So I'm going to take away one triangle, then I'm going to take away another triangle, and the rest is going to be equivalent to my trapezoid. And I won't have to use that formula and figure out what the top base is. It's going to be equivalent to the trapezoid area. All right, so I'm going to use my formula 1/2 times the base times the height. And since these two triangles have the same exact base, 3, and the same exact height, 6, I'm just going to find the area for one, and then I know that's the area for the other one. So I'm going to first find the area of both of them, the whole thing, both of them put together. I'm going to substitute 12 and 6 into my formula, and 12 times 6 is 72. So the whole area is 72. So I know that I can eliminate B and D because 72 is the area of the whole thing. So my trapezoid by itself, which is a part, should be lower than the whole 72. And both of my triangles, which are also parts, should be lower than the whole 72. So this is a part, this is a part right here, and the both triangles is a part. But this is the whole. So if I have the whole and I take away the two of the parts, the only remaining part is the area of the trapezoid. So I'm going to take away, I'm going to substitute, find my area of my triangle. So I have 1/2. I'm going to use 6 for my base because I can take half of 6. I can take half of 3 as well, but it's just easy. I can use mental math. All right, so half of 6 is 3, and 3 times 3 is 9. All right, and if this area, this triangle area is 9, guess what this is? Also 9. So I'm going to take away 9, and then the rest is going to be equal to the trapezoid. All right, so 72 minus 9 is going to give me my 63. And then I want to take 63 and take away 9, and that's going to give me 54. So 54 is equivalent to the trapezoid. So I have the area of my two triangles, which is 9 plus 9, so it's going to be 18. And then the area of my trapezoid is 54. So I need my trapezoid, which is 54, and I need my both triangles, which is 18. So I'm looking for 54 to 18, which is answer C. Now this is how you could have did this without doing any math and without thinking too hard. Okay, so you know the whole is 72. So we eliminated that by B and D because we're looking for two parts, and the two parts should be lower than the whole. So we eliminated B and D for that alone. And then we can look at the trapezoid, or look at the rectangle, look at the shape of the triangles, and recognize that the trapezoid area, the trapezoid takes up more square units. So if we have multiple choice, we only have 54 and 18. So it's either going to be the trapezoid is 18 square units or 54 square units. Both triangles is either going to be 18 square units or 54 square units. So since we can see that the trapezoid takes up more square units, we know to put the 54 square units in as the first term of the ratio instead of the second term. And without doing any math, you could have had your answer. Okay. A group of students is painting a background piece for the school play. What is the area of the part that is painted gray? So as you can see, we have a gray background right here, and then we have a door, and we have a window we can call that is not painted gray. So the first thing you want to know here is what we're painting. So we're painting all of this. So in order to figure that out, we have to decompose. But before we get into this, you need to make sure you understand the basics of shapes. So there are a few shapes that you need to know. You need to know the formula to find the area of a triangle. So that formula is area of a triangle is equivalent to 1/2 times the base times the height, because the triangle is half of a rectangle. So I can decompose this into a shape that I know into a triangle. So if I cut it here, I can find the area of that triangle if I know the base and the height to substitute into my formula. You also need to know the formula for rectangles, which is the same formula that you learned in whatever grade, probably 3rd or 4th. So the area of a rectangle is just equivalent to the number of squares along the base times the number of squares along the height. That'll give you the area for that. You also need to know the formula to find the area of a parallelogram. Now a parallelogram is just a shifted rectangle, so it's going to have the same exact formula as a rectangle. So the area of a parallelogram is just base times the height. You also need to know the formula to find the area of a trapezoid. So a trapezoid is going to have one set of parallel sides here. Now this formula is unique because you make a copy and rotate it. And because you make a copy and rotate it, you only want half of the square units. So if I make a copy of this trapezoid, rotate it, and compose it here like this, I only want half of the square units. And since I made a parallelogram, I'm going to use 1/2 times the base times the height. But the key note here is you have not just one base, but two base, because this length down here that was at the top is now added to the base at the bottom. So you would use 1/2 times the sum of the base 1 plus base 2 times the height. And remember, you only want half of the square units, which is why you multiply by 1/2 to take half of it. So those are the formulas that you need to know. For this specific question, we only need to decompose into triangles and rectangles. So I would decompose it right here. Decompose means to break apart. So we have the area. Our plan is going to be to find the area of the entire house. So this is going to be the square units for the entire house. And then we have to take away, well, we have to, the area of the entire house is equivalent to the triangle, the area of the triangle plus the area of the rectangle. Now, if you look at the rectangle closely, you can clearly see that the door and the window is not being painted. So if we want the area of the painted blue, we have to take away the door, so minus the door, which is a rectangle, using dimensions 3 and 6 right here. And then we have to take away the window, which is also a rectangle, and it used the dimensions 4 and 2. So I'm just going to go ahead and put those dimensions here, 2 and 4, so that's 8 square units here. So we need to make sure we take away 8 square units for the window. And then we have 3 and 6, so we need to make sure we take away 18 square units for the door. So I'm just going to put that in, base times height. So I need to take away 18, and I need to take away 8. All right, so I have that part done. I need to now figure out what is the formula to find the area of a triangle. So we know a triangle is half of a rectangle, so it's going to be 1/2 times the base times the height. So in order to find the area, the total number of square units for the triangle, I need to take away, I need my base and my height. So and then I'm going to put my formula for a rectangle, which is base times height. So I need to put in my base and my height. I need to put in my numbers in order to get the answers, or in order to get the square units. So the base of the triangle goes from here all the way over here. And since it's sitting directly on top of a rectangle, the length from here to here is the same length from here to here, because a rectangle have 2 sets of parallel sides. So I'm going to use 30 as my base. I'm going to use 1/2 times 30. And then for my height of the triangle, if I put a line here, here's my right angle. It looks, I don't have the height of the triangle, so I have to actually go subtract to find it. So if I look at my numbers, from the top of the house all the way to the bottom of the house is 50 square units. Now my triangle is not that long. My triangle goes from here to here. So from here all the way down here is 50 inches, 50 inches. So I know my triangle is going to be shorter than that. The question is how much shorter. So if I come over here, I can see that the rectangle's length from here to here is 40. So the whole house, the triangle plus the rectangle height is 50. So if I take that whole 50, which is from the top of the triangle to the bottom of the triangle, and if I were to decompose it, I'm taking away the rectangle, so I want to take away the height of the rectangle, which is 40. The rest is going to be the height of the triangle, which is 10. So I'm going to use 10 inches for the height of the triangle. So I'm going to put 10 right here. All right, and then I'm going to substitute my base and my height in for my rectangle. So the base is 30 and the height is 40. Substitute that in there. All right, now I'm going to evaluate. So half of 30 is 15, and then 15 times 10 is 150. And now I have 30 times 40. So 3 times 4 is 12, and then I can add my 2 zeros, 1, 2. All right. And then I need to add these two numbers together so I can align my decimals and place values. So I have 1200 plus 150. That'll give me 1,350. 1,350. But that gave me the square units of the triangle, so that's here. right? And it gave me the square units for the rectangle, which is all of this. So notice that the door and the window should not be included in that painting that I just did. So what I want to do is I want to take away the door, which is going to be taking away these 18 square units that I'm not painting, and I want to take away this window, the 8 square units. All right, so now I have 1,350 minus 18, which I did here. I had to regroup and borrow. So that gave me 1,332. And then, so that's taking away the door. Why did I take away the door? Because I'm not painting the door gray. So I don't need the square units that the door is going to take up when I found the area of the rectangle. So now I need to take away the window. Why do I take away the window? Because I'm not painting it gray. So I'm going to do 1,332 minus 8. Wait, I have to align my place values and decimals. If I were to put a decimal, it would be here. All right, so I'm going to borrow from this 3. This 3 is going to become a 2. 2, I'm adding 10 because the 1's place is 10 lower than the 10's place, or it takes 1 10 is going to make 10 1's. So I have 12 minus 8 is 4. Then I have 2 minus 0 is 2, 3 minus 0 is 3, and 1 minus 0 is 1. So I have 1,324 square units is going to be used for the gray region, or to paint the background piece gray. I'm going to need 1,324 square inches of paint, or I'm going to cover 1,324 square inches. Amara wants to draw isosceles right triangles on a coordinate plane that have two vertices at -2, 4 and 5, 4. If the coordinates of the third vertex are both integers, how many different isosceles right triangles can she draw? Fill in the blanks to explain your reasoning. Wow, so you have to know a lot of things here. You have to know how to graph points on the coordinate plane. What points do you need to graph? -2, 4 and 5, 4. So this -2, 4 is in quadrant 2 and 5, 4 is in quadrant 1. Another thing you need to understand for this question, what is an isosceles right triangle? So we need to know what that is. So let's talk about that for a second. So a right triangle is obviously going to be a triangle with a right angle. So I'm going to draw a triangle with the right angle, so it looks something like this. Now what's unique about, so we have a right angle, boom, that checks out. Now you need to know isosceles. So remember, there are isosceles deal with the length of the segment. So we need two sides that are going to be equal. So if this is 5 here, this must be 5, because that's the rule for an isosceles triangle. And this one can be whatever. As long as two of the sides are equal, then it's an isosceles triangle. So remember, you have equilateral triangles. That's where all sides are equal. So we have an equilateral triangle. So if this is 5, this is 5, this is 5, this is called an equilateral. Equal, it has that root where all sides are equal. Then you have an isosceles triangle. So it doesn't necessarily have to be a right triangle. Let's say, let's see, an isosceles triangle. No, that looks more like an equilateral triangle. So an isosceles triangle is going to be all two sides are equal. So these two sides will be equal, and this one will be different. So if this is 6, this side right here is 6, and this could be a different number right here. Let's say, let's just put a 10 there. So this is an example of isosceles triangle. So you have to know what this is. Isosceles. And then the other type of triangle is a scalene triangle. That's when none of the sides are equal. So let's draw an obtuse triangle. None of the sides are equal. All right, so let's say we have this is 4, this is 7, and let's say this is 12. This is scalene, which none of the sides are equal. So you can remember that by using your alphabet. A, B, C, D, E comes first. All of the sides are equal. After E is I. 2 of the sides are equal, so 3 equal sides. And then this one have 2 equal sides, and this one have no equal sides. Scalenes has no equal sides. So you need to know isosceles for this one. So we need a right triangle with right triangle. So remember, right triangle is, they form a 90-degree angle, 90-degree right angle. And you could also have it something like this. You could have it upside down like this, as long as you have that right angle. And let's say this is 9, this will have to be 9 as well. So this will be not to scale because this clearly looks shorter than this side. So I drew that not to scale. What does that mean? That means the picture may look different than the actual dimensions. So you actually need to look at the dimensions to see if it's an isosceles triangle, and we can say this is 12. So these are examples of isosceles triangles. So we need to know that in order to move forward with this question. All right, the next thing I want to do is graph my points. So I'm going to graph my vertex. So I'm going to start at the origin 0, 0, and I'm going to graph negative 2, 4. So I'm going to go to the left 2 units. Since my x-coordinate is negative, that's going to the left. You remember your x-coordinate tells you how to go left or right along the x-axis. And then the y-coordinate tells you how far to go up or down along the y-axis. So I'm going to go up to 4 right here. And that's going to be my ordered pair, negative 2, 4. And then I'm going to graph my other vertex, which is 5, 4. So I'm going to start at the origin 0, 0. I'm going to go to the right 5 units, and then I'm going to go up 4 units, and this is in quadrant 1. I'm going to graph that point, 5, 4. Now I need to find the distance. Since I need a isosceles right triangle, and I have 2 points with the same y-coordinate, because I had to move above the x-axis the same number of units for both of those points. So these points have the same y-coordinate. So I need to find the distance between these 2 points, and I need to make sure my other vertex produce that same distance. So I'm going to go ahead and find the distance between those 2 points. I'm going to write my ordered pairs down. So I have negative 2, 4, and then I have 5, 4. Since my y-coordinates are the same, I'm not going to use them to find a distance. I'm going to use the x-coordinates, and I'm not going to add them. I'm going to add the absolute values. Whenever you're dealing with distance, it's so important for you to say add the absolute values. So I'm going to put the absolute value of 5 plus, since I have two different quadrants, I want to add the absolute values, the absolute value of negative 2. So 5 plus the absolute value of negative 2 is 7. So they are 7 units apart. Now, since the scale is going by ones, we could have counted 1, 2, 3, 4, 5, 6, 7. If we would have added these 2 points together, negative 2 plus 5 is actually positive 3. So you don't want to say add the 2 points. You want to say add the absolute value. So keep that in mind. All right, so now that we know our units, our distance is 7 units, we need to make another. We need to figure out where could that missing vertex be. All right, so let's look here. So it says for the right triangle to be an isosceles and both coordinates of the third vertex be integers. So you need to know what that means. So integers is going to be whole numbers, their opposites, and 0. So we're not making half of points. So you have to know what the word integer means as well. So let's go ahead and highlight that. A whole number is opposite, and 0 is what a integer is. All right, same from one of the 2 given vertex to the third vertex must be a length of, so we know it must be a length of 7. We just found that out by finding the distance. And be parallel to the blank axis. So we ran into another vocabulary where we have to know what this word parallel means. So parallel is like this, 2 lines that never cross, and they have the same slope. So this is also parallel. They're going this way as long as they have the same slope and they're going in the same direction. So basically it's 2 straight lines. You could also have parallel like this, or you could have parallel like this, but it's not going to be all of this. But that's what parallel looks like. So it must be parallel. So the vertex must be a length of 7 units and be parallel to the y-axis. Must be parallel to the y-axis. All right, so it says so parallel, so it's going to be going straight up and down to the y-axis. So since we already have two vertex here, we can only make points parallel, so going in the same direction as the y-axis, not going parallel with the x-axis this way. You want to be parallel to the y-axis, straight up and down. All right, so it says the y-coordinate for the third vertex must be blank or blank. The y-coordinate, so they're talking about up or down. So since the length from here to here was 7 units, 2, 3, 4, 5, 6, 7. So since the length from there was 7 units, let me go ahead and mark that. Then from here to here is 7 units. I'm going to make a vertex going down. So I need to go 7 units down. So I'm going to go to find my other vertex, because it has to be isosceles. So if this is 7 units, I need 7 units going down, or 7 units going up. 2, 3, 4, 5, 6, 7. So here's I'm going to make my first triangle right here. So this is going to be my first triangle. And that vertex is -2, -3. All right, so this is my first triangle. I'm going to go ahead and color it in. I'll do this light color. No, I'll do red. I'm going to color it in red. So this is the first triangle that I can make. That's isosceles. That's a right triangle, so everything checks out. So this is my triangle, my first triangle. Here's my right angle right here, and I have 7 units, so it's scalene triangles. Now so my y-coordinate must be -3. So I can go 3 units down, or I can go 3 units up. Now since I don't have any more coordinate plane, I'm going to take my ordered pair, which is -2, 4. And since I want to go 4 units up from my y-coordinate, I want to go 7 units up from my y-coordinate. I'm just going to add 7 units to my y-coordinate. So it'll be 7, 8, 9, 11 for my y-coordinate, and -2. So that would be the other vertex there, -2, 7. So my y-coordinate needs to be -3 or +11. And then she can draw blank triangles. So this is one triangle that I can make. So let's explore our options here. We could also make a triangle. So using these same 2 points that was in the original problem, I can also go 7 units down here. 1, 2, 3, 4. Well, actually, I'm just going to take my ordered pair, because I want you to know how to shift. I'm going to take my ordered pair 5, 4, and I want to go 7 units down. So since I'm going up and down along my y-axis, I'm going to take away 7 units from my y-coordinate. So my new ordered pair is going to be 4 minus 7. If you start at +4 and you try to take away 7, it's going to take you 4 units to get to 0, and then you're going to go in a negative direction 3 more units. So it's going to be -3 for my y-coordinate, and my x-coordinate is going to stay the same. So my ordered pair will be at 5, -3, which is here. So this is going to be my second triangle, my second right isosceles triangle. And I'm going to go ahead and graph that point. So we'll go here to here. That's my first line segment. Here's my second line segment going from here to here. And here is my third line segment. And now I have a polygon on the coordinate plane. So this is my second right triangle using those same 2 vertex. Now these are not the only triangles that I can make. So that's 2 so far. I can make 2 more. So remember, I can go up to -2, 11. So I'm going to go, let's just say it's right here. So this is -2, 11. I should have put it over here. That would have been better. So that would be my other vertex, and I can make a triangle here. So using those same two line segments, so I have -2, 4, and 5, 4. And then I'm going to make my third line segment here. Now I made a polygon on the coordinate plane. Alright, so that's my third one. I'm going to fill that in green. So that's 3 triangles. And of course I can make one more using those 2 points. -2, -2, 4, and 5, 4. So I will start with my 5, 4, and then I need the length to be 7 units, so I'm going to go and I'm changing my y coordinate because I'm going up or down, and since I'm going up, I want to add 7 units to my y coordinate, so that'll be 11, and my x coordinate is going to stay as a 5, so that would be my order pair there. 5, 11. Alright, so I'm going to go ahead and make my polygon by closing my line segments. So I have remembered that original point, my first vertex, and then going from this vertex to my 5, 11 is going to be my second line segment, and then going from my vertex -2, 4 to 7, 11 is going to be my last point. So I can make a total of 4 triangles. So here you see all 4 triangles. And then I'm going to color that in so you can see it. So the answer that we will put here is 4. All of that work for 4 triangles. 4 triangles.